Hi, now going through the answers to lesson 7. First of all, I asked for pairs of equal and opposite forces on a rocket. Well, there were two we already had on a bullet, air resistance and pushing back against the air, and then the weight of the rocket, and then the rocket actually pulling the Earth towards it. But also there's lots of other things you could have had. Some people talked about the fuel being ejected out, having an equal opposite force on the rocket forward. That's just how a rocket works. Some people even talked, and we liked about this, about the shearing forces. The rocket's got stabilisers, so there's going to be equal and opposite forces there as well. So lots of things you could have had for that. The balls. I think many of you immediately, by the looks of your answers, went and watched the answer video that was next to the video I posted. That's absolutely fine. Well done for showing the initiative. For anyone who wasn't sure about what was going on, these balls will have a buoyancy force on them. They float, they want to get up, so there's a buoyancy force there. We know from equal and opposite forces that there'll be another buoyancy force, so the opposite of the buoyancy force, applying downwards on both beakers. So far so good. The only difference, therefore, is the position of this string. This string here is going to have nothing to do with this beaker. They're not interacting in any way. However, this string here is going to have tension in it. Because the ball is pulling up, and therefore this one overall is going to be far lighter. That's the difference between the two. Good stuff. Finally, I asked you, does Newton's third law apply to the weak force? The answer here, did a lot of research of this over the day. No, it doesn't. Simple reason here, Newtonian mechanics only applies to rocks and stuff a bit like rocks. By the time we get down to weird stuff like the weak force, all sort of breaks down a bit. But a few really good answers in the comments about that, so well done.